Hello friends, I am Balaji Rao. Welcome to BR Max class. This is last class on Principle of Mathematical Induction. In this class, we will do 4 problems. You observe this statement. We need to prove this statement by using Principle of Mathematical Induction. First, I'll take given statement as P of n. You observe here, I considered given statement as P of n. To prove any statement by using principle of mathematical induction, we need to prove 2 things. First, we will prove P of 1 is true. Next, by assuming P of k is true, we will prove P of k plus 1 is true. So, first part of this problem, I want to prove P of 1 is true. See here, in place of n, I written 1. X power 2 into 1, that is x square, minus y power 2 into 1, that is 2 square. X square minus y square is divisible by x plus y. I got this statement. See this x square minus y square, it is of the form a square minus b square. So x square minus y square can be written as x plus y into x minus y. You observe here, now what we got? We got that x plus y into x minus y is divisible by x plus y. Try to understand a particular point. You see here, if 10 is a multiple of 2, 10 is divisible of 2. If 18 is multiple of 6, then 18 is divisible of 6? Yes, of course. Similarly, you observe here this expression x plus y into x minus y. You observe this full expression x plus y into x minus y. Is it a multiple of x plus y? Easily we can say this full expression is multiple of x plus y. If this expression is multiple of x plus y, can I say this is divisible of x plus y? The same thing we got here. You look here. This expression is divisible by x plus y. Now we need to confirm whether it is true or not. As this expression clearly multiple of x plus y, definitely it will be divisible by x plus y. That means whatever you got here, that is true. I hope you are understanding. Why we got this statement? Because we put n equal to 1 in the given statement. As this is true, we can conclude that P of 1 is true. Now comes to the second part. What is second part? You assume P of k is true, and from that you prove P of k plus 1 is true. First, I'll assume P of k is true and I'll write what is P of k. You observe here, I assumed P of k is true and I written P of k. This is P of k. How you will get P of k? In this P of n, wherever n is there you write k. Then you will get P of k. Here you see x power 2k minus y power 2k is divisible by x plus y. You assumed that this statement is true. You assumed it is true. That means this expression is divisible by x plus y. This expression is clearly multiple of x plus y also. For example, you take 10. 10 is divisible by 2. Yes. Is 10 is a multiple of 2? Of course. So what I am trying to say here, x power 2k minus y power 2k is divisible by x plus y. It means that x power 2k minus y power 2k is multiple of x plus y. Try to understand this. As it is a multiple of x plus y, what I can write? I can write x power 2k minus y power 2k as x plus y into some integer p. Here, what is p? Where p is integer. I'll write one more simplification step from this. X power 2k equal to x plus y into p. You take minus y power 2k to the right hand side, then it is plus y power 2k. I got this information from P of k. Now, what is our intention? By assuming P of k is true, we are trying to prove P of k plus 1 is true. To prove P of k plus 1 is true, it is important to know what is P of k plus 1. That's why I written what is P of k plus 1 here. How you will get P of k plus 1? In P of k, wherever k is there you write k plus 1. You see here, this is P of k plus 1. Now our intention is we are trying to prove P of k plus 1 is true. So what I'll do, I'll consider this part. X power 2 into k plus 1 minus y power 2 into k plus 1. I considered this expression. Now my intention is I need to prove that this expression is divisible by x plus y. What I'll try to do here, I'll try to prove that this expression is multiple of x plus y. If this expression is multiple of x plus y, then I can say that this expression is divisible by x plus y. You just start simplifying this. You see here, multiply with 2, x power 2k plus 2 minus y power, multiply with 2, y power 2k plus 2. I just want to use x power 2k. So what I will do here, this is like a power m plus n. A power m plus n can be written as a power m into a power n. And you observe here, y power 2k plus 2. This also can be written as y power 2k into y square. Okay. Now you observe here x power 2k. You observe this one. In this, x power 2k is there. So in this expression, in place of x power 2k, I will write this. See here, in place of x power 2k, I written x plus y into p plus y power 2k into x square minus y power 2k into y square. Okay, let's simplify further. You multiply, you see here, this expression into x square plus this expression into x square. Okay, start multiplying. I do not want to disturb this x plus y. I'll keep x plus y as it is because I am trying to prove that this is a multiple of x plus y. If this is a multiple of x plus y, then only I can say that this is divisible by x plus y into x square plus y power 2k into x square minus y power 2k into y square. Okay, that equal to, I'll write this first term as it is, x plus y into p into x square plus. You observe these two terms. In these two terms, what we can take common? You see here, y power 2k is there. You see here also y power 2k is there. So I can take y power 2k common. Take y power 2k common. What are remaining? X square minus y square. You see, I'll simplify this further. We will see what I'll get. X plus y into y power 2k into, you look here, this x square minus y square, that can be written as x plus y into x minus y. Okay, you observe here we have two terms. This is the first term, this is the second term. In this term x plus y is there. In this term also x plus y is there. So you take x plus y common. Okay, you take x plus y common. What you will get? Here p x square plus, if you take x plus y common, what you will get? Y power 2k into x minus y. You can observe here, what we got here? We got that x power 2 into k plus 1 minus y power 2 into k plus 1. I got this expression as multiple of x plus y. If this is multiple of x plus y, we can say that this is divisible by x plus y. So we proved that this expression is divisible by x plus y. You know what is p of k plus 1. This is p of k plus 1. That means what happened? By assuming p of a is true, we proved that p of k plus 1 is true. So we proved two things in this. First, I proved p of 1 is true. Next, by assuming p of k is true, we proved p of k plus 1 is true. Therefore, by principle of mathematical induction, we can say that given statement p of n is true. Hence, we proved this statement by using principle of mathematical induction. Let's move to next question. We need to prove this statement by using principle of mathematical induction. First, I'll consider given statement as p of n. Now, we need to prove two things. First one, I'll prove p of 1 is true. P of 1, that means in place of n, I'll take 1. In this statement, wherever n is there you write 1. 3 power 2 into 1 plus 2 minus 8 into 1 minus 9 is divisible by 8. I got this statement when I put n equal to 1 in the given statement. I simplified this. Then I got 64. 64 is divisible by 8. Is 64 is divisible by 8? Is it true? Yes. 8 times 8 8s are 64. So 64 is divisible by 8 is true. So we proved first part of this question. Second part, you assume p of k is true and you need to prove p of k plus 1 is true. First, I'll assume p of k is true and I'll write what is p of k. You observe here, I assumed p of k is true and I written p of k. How you will get p of k? In this statement p of n, Wherever n is there you write k. This is p of k. This is p of k. What is this statement? This expression is divisible by 8. If a number is divisible by 8, definitely it is multiple of 8. For example, you take 24. 24 is divisible by 8. Yes, of course. You can observe that 24 is multiple of 8 also. Like that, 64 is divisible by 8. When it is divisible by 8, we can easily write that it is a multiple of 8 also. So here, this expression is divisible by 8. It means that this expression is multiple of 8 also. So what I can write? I can write this expression as 8 into some integer. Now I'll write one more simplification step. You just observe here, I taken minus 8k minus 9 to the right hand side. What is our intention? By assuming p of k is true, we are trying to prove p of k plus 1 is true. So it is important to keep in your mind what is p of k plus 1. See, this statement is p of k. In this expression, in place of k, you write k plus 1. Let's see what we will get. You see here, in this expression, in place of k, I written k plus 1. Now what I am trying to prove? If I prove that this expression is divisible by 8, I can say that p of k plus 1 is true. In the process of proving p of k plus 1 is true, we will use this information. You keep that in your mind. Okay, let's start simplifying this. 3 power multiply with 2, 3 power 2k plus 2 plus 2 minus multiply with 8, what you will get? 8k minus 8 minus 9. Okay, you observe here this part, it is like a power m plus n. A power m plus n. A power m plus n can be written as a power m into a power n. Remaining all I write as it is, minus 8k minus 8 minus 9 is minus 17. Now, in place of 3 power 2k plus 2, I'll use this information. In place of 3 power 2k plus 2, I'll write 8p plus 8k plus 9 into 3 square. 3 square is what? 3 square is 9. Minus 8k minus 17. In the process of simplifying, wherever 8 is there, you do not disturb that term. Okay. So multiply with 9. So I'll write 8 as it is. 8 into 9p plus 8 into 9k plus 9 9s are 81 minus 8k minus 17. You see here, in this term 8 is there, in this term also 8 is there, in this term also 8 is there. 81 minus 17 is 64. 81 minus 17 is 64. That means in all these terms you can take 8 common. So take 8 common, what you will get? You will get like this, 9p plus 9k plus, see 81 minus 17 is 64 now. So if you take 8 common, 8 will be remaining, minus k. You please observe here what happened. We identified that this expression is multiple of 8. If a number is multiple of 8, then definitely that number is divisible by 8. What I am trying to say, this expression is multiple of 8. If this expression is multiple of 8, this expression definitely divisible by 8 also. This is divisible by 8. What is this? This is p of k plus 1. What I can write here? I can write that p of k plus 1 is true. What happened? We did two things. First, I proved p of 1 is true. Next, by assuming p of k is true, we proved p of k plus 1 is true. Therefore, by principle of mathematical induction, we can say that p of n is true. So, we proved given statement by using principle of mathematical induction. Now, we will move to next question. You see this question number 23. 41 power n minus 14 power n is a multiple of 27. I need to prove this statement by using principle of mathematical induction. First, I'll take given statement as p of n. You observe here, I considered given statement as p of n. Now, I need to prove this statement by using principle of mathematical induction. To prove a statement by using principle of mathematical induction, we will prove two things. First, we will prove p of 1 is true. Second one, By assuming P of k is true, we will prove P of k plus 1 is true. First, I'll prove P of 1 is true. Let's see how we will prove P of 1 is true. You observe here, I need to prove P of 1 is true. So, in place of n, I'll take 1. In this statement, wherever n is there you write 1. 41 power 1 minus 14 power 1 is a multiple of 27. 41 power 1 is 41 minus 14 power 1 is 14 only. 41 minus 14 is 27. 27 is a multiple of 27. Is 27 is a multiple of 27? Is it true? Of course, we all know that 27 is a multiple of 27. This statement is true. We got this statement because we took n equal to 1. It tells you that this statement is true for n equal to 1. It tells you that P of 1 is true. Now second one, assuming P of k is true, you need to prove P of k plus 1 is true. You observe here, I assumed P of k is true and I written P of k. How you can write P of k? In this statement P of n, wherever n is there if you write k, then you will get P of k. Now, as this is a multiple of 27, I can write like this. You see here, 41 power k minus 14 power k equal to 27 into some integer. If I take this minus 14 power k to the right hand side, it will become plus 14 power k. Now, our intention is we are trying to prove P of k plus 1 is true. It is important to keep in your mind what is P of k plus 1. You observe here, this is P of k. In this, in place of k, you write k plus 1. Then what you will get? 41 power k plus 1 minus 14 power k plus 1 is a multiple of 27. We are trying to prove that. I just consider this expression. I'll simplify this and I'll prove that it is a multiple of 27. Then I can write P of k plus 1 is true. You observe this part. In the process of proving that, I am going to use this information. And you observe here, it is in the form of a power m plus n. What is the formula of a power m plus n? A power m into a power n, okay, minus. Similarly, 14 power k plus 1 can be written as 14 power k into 14, okay. Now, you observe here, 41 power k is there. In place of 41 power k, I'll write this expression 27p plus 14 power k. So, 27p plus 14 power k into, you see here, into 41 minus 14 power k into 14. Good. Now, what I'll do, you keep in your mind, we are trying to prove that this expression is multiple of 27. Whenever you got something like 27, you do not multiply with that another number. You keep 27 as it is. So here you multiply these things. What you will get? 27 into p into 41, that is 41p plus 14 power k into 41 minus 14 power k into 14. Okay, that equal to 27 into 41p plus. You observe these two terms. What I can take common? I can take 14 power k common. If I take 14 power k common, what is remaining? 41 minus 14. That equal to 27 into 41p plus 14 power k into 41 minus 14. 41 minus 14 is what? It is 27. Okay, right. Now you observe in this term 27 is there. In this term also 27 is there. So I can take 27 common. So you take 27 common. What you will get? 41p plus 14 power k. What happened? We proved that 41 power k plus 1 minus 14 power k plus 1 is a multiple of 27. So I'll write here. Therefore, 41 power k plus 1 minus 14 power k plus 1 is a multiple of 27. What is this statement? This statement is P of k plus 1. Therefore, P of k plus 1 is true. What happened? We proved two things in this problem. First, I proved P of 1 is true. Next, by assuming P of k is true, we proved P of k plus 1 is true. Therefore, by principle of mathematical induction, we can say P of n is true. Hence, we proved this statement by using principle of mathematical induction. Now, we will move to next question. This is last question in principle of mathematical induction, and this is not easy question. This is little difficult to understand. Okay, we need to prove this statement by using principle of mathematical induction. Which statement we are trying to prove, we will take that statement as P of n. You observe here which statement I am trying to prove. I considered that statement as P of n. To prove any statement by using principle of mathematical induction, we need to prove two things. First, I'll prove P of 1 is true. Next, by assuming P of k is true, we will prove P of k plus 1 is true. First, I'll prove P of 1 is true. To prove P of 1 is true, I'll take n equal to 1. I'll substitute it in the given inequality. In place of n, I written 1. You see this left hand side part, this will become 9. In right hand side part, if we put n equal to 1, 1 plus 3 is 4, 4 square is 16. What I got here? I got 9 is less than 16. Is 9 is smaller than 16? Of course, it is true. That means this statement is true for n equal to 1. So what I can say? I can say that P of 1 is true. So first part of this problem is completed. Second part. In second part, by assuming P of k is true, we need to prove P of k plus 1 is true. So first I'll assume P of k is true. You observe here, I assumed P of k is true. And I written what is P of k. How you will get P of k? In this P of n, wherever n is there, there you write k. It is important to keep in your mind what is P of k plus 1. So first I'll write P of k plus 1 here. See, this is P of k plus 1. In this P of k, wherever k is there, there I written k plus 1. Now I am trying to prove this. I am trying to prove P of k plus 1 is true. So you observe here, this is 2k plus 2 plus 7. 2k plus 2 plus 7, that is 2k plus 9. I need 2k plus 9 in the left hand side. You look here, here 2k plus 7 is there. To get 2k plus 9, I'll add 2 to this inequality on both sides. Just to get the answer, you add 2 to this inequality on both sides. You observe here, we know that for an inequality, if we add a number on both sides, inequality remains same. Okay. Now you see here, I got left hand side part of P of k plus 1. What I'll do, in this 2k and 2, in these two terms, I'll take 2 common. You will get like this, 2 into k plus 1 plus 7 is less than. You expand this k plus 3 whole square, what you will get? K square plus 9 plus 6k plus 2. Okay. If I simplify this further, you will get k square plus 6k plus 11. Now what I will do, that is important. What I am trying for? I am trying to prove P of k plus 1 is true. You see, this is P of k plus 1. You expand this k plus 4 whole square, k square plus 16 plus 8k. Here, I'll compare these two things. To do this problem further, I'll consider few things here. You see, what are those things? Here, k is a natural number. For any natural number k, 6k will be smaller than 8k. We know that 6k is less than 8k. Here k is natural number. You take k as one natural number, you substitute both sides. You will easily identify that 6k is less than 8k. And another easy point what I know, 11 is less than 16. How I am considering these things? You see here 6k is there. Here 8k is there, 6k less than 8k. And you see here 11 is there, here 16 is there, 11 is less than 16. By considering these things I written here, I know these things. Okay. Now from inequalities chapter, I know this. If A is less than B, C is less than D, then what I can write? I can write that A plus C is less than B plus D. I can write like this. A plus C is less than B plus D. So here what you can write? you can write that 6k plus 11 is less than 8k plus 16. I'll add k square on both sides. What is k? K is a natural number. K square is also natural number. For an inequality, if we add a natural number on both sides, inequality remains same. So I'll add k square to this on both sides. You see here what I got. I got k square plus 6k plus 11 is less than k square plus 8k plus 16. So this information I am going to use. Now you come back to this expression star. From this what I can write? I can write that 2 into k plus 1 plus 7 is less than. From this I am writing this k square plus 6k plus 11. Now you see this one. What I got just now, k square plus 6k plus 11 is less than k square plus 8k plus 16. We got this now, right? Now you see this point. If A is less than B and B is less than C, then what we can say? We can say that A is less than C. It's simple thing only. Suppose 2 is less than 4. 4 is less than 6. Is 2 is less than 6? Obviously, here you look here, it is like A is less than B is less than C. What I can write from this? I can write that A is less than C. So 2 into k plus 1 plus 7 is less than k square plus 8k plus 16. So if I write one more step, 2 into k plus 1 plus 7, you can observe this. What is this? This is k plus 4 whole square, correct? What is this? This is p of k plus 1. So we proved that p of k plus 1 is true. So what happened? We proved two things. First, I proved p of 1 is true. Next, by assuming p of k is true, we proved p of k plus 1 is true. Therefore, by principle of mathematical induction, p of n is true. Hence, we proved given statement by using principle of mathematical induction. With this, we completed this chapter successfully. If you felt these videos are useful, please drop a like. Subscribe to my channel. Share these videos with your friends.